Greg? We may actually have some before that, don't we? I think I may have one in February. All right. Parallel lines. And proportional parts. Okay. I would imagine, we've been talking about proportions, right? We've been talking about similar triangles. This is going to probably go with some of that stuff. If you're not done writing down those theorems, leave yourself some space. Basically here, I'm going to go over those theorems one by one. So you've already got them written down, so all you can, now you can just listen, okay, as we talk about them. First theorem is a biggie. Iron triangle. Call this triangle A, B, C. Okay? What we're going to do is say, what if we drew a parallel line inside of that triangle, parallel to one of the sides? So stop writing the theorem. So what I'm going to do is I'm going to draw a line parallel to BC here. Or in essence, I'm going to draw a segment. Actually, I'm going to purposely not draw it even where it's even remotely close to being in the middle. That has nothing to do with this. What do these arrows mean again? Okay, so make that D and make that E. So I'm saying that DE is parallel to what? BC. Okay. Some special things happen here. Basically, what happens is you create two similar triangles. Okay? That's what drawing that parallel line inside there did. Now, if I was to write a similarity statement, what do you think are the two triangles that are similar here? The triangle, start with the larger of the two, which would be triangle what? A, B, C is similar to triangle. Well, now I'm talking about the smaller triangle that was created inside the larger, correct? Stop writing. Which is triangle what? AD. It's important that we understand that. Because don't those two triangles look similar? Would you agree with that? Okay, so let's write the proportional parts. First of all, let's go with the larger to smaller. BC over what? What corresponds to BC? DE. That would equal, well now I need to write two more corresponding. And here's where you're going to have to kind of be a little creative in the way you look at this. What corresponds to this side right here? Huh? AD does. See how this corresponds, the smaller part corresponds to the bigger, so it would be AB, which is this whole side over what? AD. Everyone see that? Which is equal to, what's this whole side? AC over AE. Or you could have done it the other way. You could have done smaller over what? Larger. You guys see the proportional parts there? You guys see, some people are good at visualizing that. Do I need to draw the two triangles separate? Okay. Now, what's new here in this theorem is they say, well, because these are one triangle inside of the other, there's a set of proportional parts that's made. Also, this always happens. This is where the proportional parts comes from. Okay? Part, you think of part of something, right? Not the whole thing. Well, what happens is this parallel line right here will always, if it's parallel to this side, it will always cut this into proportional parts. What did it cut? What parts did it make? So AD over its proportional part is what? DB will equal what? AE over, what is its proportional part? EC. Now what's the difference there? AD and AE are sides of a triangle, but what about DB and EC? What is that? That is just what? Part of the triangle, isn't it? That's where the word proportional parts comes from. Okay? So you can visualize that. I can label this. It basically always looks like this. If this was X, and this was Y, and this was W, and this was Z, when this is parallel to this always works out. X over Y is equal to what? W over Z. So you see that? Does that make sense? You still have two parallel, you still have two similar triangles here. Because they're going to ask you to use both of these. But you also have some proportional parts that are made. This over this equals what? That over that. The main thing to remember is the longer part over the other longer. The longer part's on top, the shorter part needs to be on bottom of both sides, right? Question? You okay there? And then, of course, there's a theorem that says the converse of this. Let's say I didn't tell you these were parallel, and you found out that this over this equals what? This over this, then you could say that what? This has to be parallel to that, the converse of it. Any other questions? Okay, the other theorem in this section, it kind of is along the same lines. So let's say I have three parallel lines drawn. These are all parallel. Okay? And I draw two lines through it like that. Okay? Does this somewhat look like this? And what did I say? That X over Y would always equal W over what? When these are parallel, X over Y equals what? W over Z. Proportional parts, right? Well, they extend this there to include what? What's the difference between this picture and this picture? Yeah. In this picture, what do the two lines do? They meet to form a what? Triangle, don't they? Is this in essence the exact same situation? It's just that these two lines didn't what? Actually meet. So if this was X and this was Y, this distance was W and this was Z, what do you think I can say about this? X over Y would equal what? W over Z. Do you see how that's really the same thing? It's just this one didn't, the part didn't form a what? Triangle. But I still had proportional parts. Make sense? Any questions on that? Okay, last thing deals with midsegments. A neat little thing happens when a triangle. Now what is the mid-segment? So, you guys tell me when you think I'm in the middle right there? What do you think? Right there? Tell me when you think I'm in the middle right here. Right here? You guys think that looks about right? Maybe about right there? Doing good. That's a mid-segment, is it not? What do you think this line is to this one? It's going to be parallel. Now, let's call this A, B, C, D, E. There's something that ends up happening here. Okay, when you have a mid-segment drawn, what does it say on page 4? Draw a mid-segment, they're parallel, and what? If this is x, what's this? 1/2 of x. Or you could write it as this. DE, the smaller one, is equal to 1/2 what? The one it's parallel to, CB. Questions there? We okay there? A lot of different theorems in this section, but they all kind of relate to each other. The last one is really common sense. If I have 3 parallel lines, I didn't do a very good job of drawing them. And I draw one of these, and I say that this distance is equal to that distance. What am I saying? That we have parallel lines that are the exact same distance apart, aren't we? Isn't that what that means? I'm saying this distance right here is the same as this distance right here. What do you think is going to happen if I draw, what do you think I can say if I draw another line? What's always going to happen? Isn't that always going to be equal to that? No matter how I draw it? Aren't they always going to be the same because that line's going to stay straight and this distance stays what? The exact same. So no matter how you draw a line through there, what are these distances going to be? Congruent, right? The distance along that same line. Look at your paper. Look at your paper. You guys have all got a bunch of parallel lines, don't you? That are the same distance apart. Isn't that what notebook paper is? Can you guys look at your notebook paper, or put you to sleep to look at your notebook paper? Isn't your notebook paper a bunch of parallel lines?
Yes. Yes.
The same distance apart. If you took a ruler or something and you would cut that into equal parts each time, no matter how you drew that line, wouldn't you? Okay? And that's what the last theory is about. Okay, let's get out those red workbooks. On the first part of 7.4, let's work on some problems. Try to do one problem of each type, 4 at a time. Turn one of those light switches off over there. Found that it shows up a lot better if I do that. Perfect. JK is what? J to K is 7. K to H is what? 21. J to L is 6. What do they ask us to find? They want us to find that. So what could we do? We make that a variable maybe? How about we make it X? Now, normally we wouldn't be able to do this until this section because, well, actually we could. You could do it the really hard way and use the triangles. Or we could say, hey, I found out that I had a theorem that said what? When this is parallel to this, it creates what? Proportional what? Parts. Right? Name of the section, proportional parts. I didn't ever, and the thing is, I can't say this is half of that or that deal because this is not a mid-segment, is it? So what I know is this smaller part up here over the larger part would equal the what? Smaller part of the other over the what? So what would my proportion be? Someone tell me. 7 over is equal to? Any questions there? Or was I expect to see that on your paper and see it solved? 7x is equal to 126, is that correct? What's x equal to? Is that correct? So I found x. Okay. Any questions there? We okay there? If I need to write it down, we're good. And like I said, always remember, I'm recording this. The reason I do that is so you guys go back onto the website and watch in case you didn't get something written down and need to watch it. Okay. RU is what? Okay. US is what? TV is what? And VS is what? Am I going to use the fact that I have two similar triangles here, or am I going to use proportional parts? Because what you're going to find is that on some of these, you're going to need to use similar triangles. And you need to be able to recognize, am I using proportional parts, or am I using similar triangles? Because if you're using similar triangles, you have to do side over side, correct? Not part over part. And that's where a lot of people make mistakes on this. And then we'll have to do one. If they don't have one up here, I'll do one up here, where they kind of mix them. And you'll see what I mean when I do this. But right, for this one, we're using what? Proportional parts. So what would my ratio be? Okay, we can do 8. 8 over 14 is equal to, well, if I did 8 over 14, what do I have to do over here? You guys over here on the right, please tell me if I get creeping over there and you need to see. I don't mind writing like that. It's just every once in a while you get forgetful. Okay, I need to cross multiply. What's 8 times 17.5? 8 times 7 is what? Huh? Is equal to 14x minus what? 14. I gotta multiply the 14 times the x and the 14 times negative 1. What am I gonna do now? Got 14x is equal to what? 154. Divide both sides by 14. Huh? 11 even. Okay, not very nice. This one, the next ones, they want us to justify whether BC is parallel to DE. How can I do that? I must, if this is parallel to this, what do I know about my parts? They have to be what? Proportional. Okay? So, AD, in this case, AD is what? 15? DB is what? 12? And in this case, they say AE is 10. And this one is what? EC is 8. So, is 15 over 12 equal to what? 10 over what? You guys know another way to easily see whether these are equal without having to reduce fractions? When we have a proportion, what can we always do? Cross multiply. So if you don't like reducing fractions, you know what else you can do? Cross multiply and see if you get the same number. What is 15 times 8? Somebody tell me.
120.
If these aren't proportional, then what should I get on the other side? 120. What is 12 times 10? So, yes, they are parallel. Did I justify my answer? Yes, I did right there, didn't I? Isn't that what all of this actually is? The justification? Any questions there? Off the side, what I'm going to do is I'm going to do another problem. Okay? I'm going to call this one 2A. Let's say SU is equal to 10. UR is equal to 4. UV is equal to 8. What is RT equal to? So write this off to the side. I don't know if you maybe, because I want you to have this example, or I guess you could watch it later. We're going to use the same picture. Tell me what is different about this. Well, you're probably going to have to label it to see what's different, aren't you? How about, this will be the last one I'll do. And I'll leave it up here for you guys to see. Okay? So everybody, no writing, pay attention. SU is 10, correct? UR is 4. UV is 8. And they asked me to find what? RT, so we'll call it what? Now, this is one where people make a lot of mistakes. The reason being is, am I dealing with proportional parts, or am I dealing with similar triangles? When are you dealing with proportional parts? When you actually have parts of the triangle, correct? Because this part, UR is a part, isn't it? When you do proportional parts, you have to be dealing with the other proportional parts. And do I know anything about this? No. So actually, what am I dealing with? The what? Two similar triangles. And if I was to draw them separately, it'd be the smaller triangle, which would be S. Then what would this be? U, and then what? Everybody with me there? And then the larger one would be what? S R T. But you can see it. Now, what what is this one? This is what? 10, this is what? Everyone agree? What's this? This is x. What's SR? That's what I've been getting at this whole time, isn't it? A lot of times write it as parts, but actually when we're using similar triangles, you have to use this whole side SR, which is actually 10 what? 10 plus what? This part plus what? Making the whole part what? So when I set up my proportion, this one's going to need to be 10 over what? 14 is equal to what? 8 over what? Look at that for a second. You guys get that? Did you guys see how I had, because I'm going to talk about similar triangles here, not proportional what? Parts. So as a result, when I cross multiply, 10x is equal to what? 112? X is equal to